See y'all again. All right.
So if we run out of things to say and run out of comments, which I don't think we will, well, we'll do a little bit of preview as to what's going on in the sky. But, I've got that in my back pocket if we need to do that at the end.
All right, sounds good. I think this is going to be an interesting one. I think we'll have lots to talk about. So it should be fun. All righty. Okay, just quickly a quick question from Janine. We nice to see you and nice to see everybody again. It's just nice to be back after quite a long break. We're going to run, we say we're going to run for an hour and a half until 5 p.m. Eastern time. But if we end before that, sometimes we don't want to run out of time at an hour. So we say we run until 5 p.m. We'll see how it goes.
Yeah, usually we fill it up. Sometimes we run over. I don't like running over because I like people to be able to count on us. So
yeah, that's why we made it an hour and a half, because we kept running over on the hour. It's nice to see everybody. Thanks everyone for saying hi. As per usual, if you're not sick of me saying this yet, if you do want to talk to everybody in the chat on Zoom, make sure that you change your little blue bar from panelists to panelists and attendees, where it says where you're sending the messages to. So then everyone can see it. We've got folks from all over the place: Toronto, Oshawa, Killaloe, Ottawa, London, lots of cloud, unfortunately, Horseshoe Bay.
We might get some clear tonight in Toronto, maybe.
Oh yeah?
Yeah, maybe.
Oh, it's been a really cloudy winter. I don't know about all of you, but here
it's
at least
like this.
I know.
It's like it's almost like childbirth, where you forget, but every year I don't forget, because I've gotten sad too many times in the winter because of clouds. And you meet these new rasks, people that have joined, they just got their telescope and they're all excited to get out there, and you say, sorry, unless it's 30 below in February, you're probably not going to be out there until the spring. But
that's the problem. And when it is 30 below, it's like not the most fun you could have outside. Yeah. Well, good for you for remembering, because I certainly don't remember. Oh, and we have someone joining on YouTube from Kansas. So I'm envious of what your weather must be like at this point. Anyway, well, today we're going to be talking about, we don't usually turn to clickbait for these videos, but we're going to be talking about a clickbaity topic. And we're going to talk about the science behind astrology, which I know is going to send about 1,000 astronomers into conniptions, because that's not something you normally hear. But we were inspired by a couple of things, but one of the main reasons was that we had a fantastic talk. We hosted a fantastic talk before the holidays about the Star of Bethlehem, and it talks about the role of astrology in that story. And it was fascinating. I have the link. It's the last video that was up on our YouTube channel, so I'll just post it in the chat if anyone is interested in taking a look at it. It's a really good topic, and it goes into it doesn't argue whether or not anything specific happened. It just talks about the role of astrology, which was the science at the time, and what people believed in the story. So super interesting, worth a watch if you're interested. We're going to be talking about all of the things like the terminology that's used in astrology and its role throughout time and its origins and all that sort of stuff today. I'm looking forward to it. I think it's really cool.
Yeah. Well, I think we should both admit right off the top that we're not astrologers and we're not experts. We do aim to get the astronomy correct, but we may not get the astrology correct. So if you're an astrology enthusiast and you're watching, please don't yell at us too much. We really want to use this as it's interesting. It's interesting how astronomy and astrology share the same origins. They lived together in harmony for for a long, long time. And at some point they diverged, but not in every respect. And I just thought it's interesting. I write my weekly Skylights blog, and I have people who are subscribers that are there for the things in retrograde, things that they're stationary notes, things like that. They're interested in what's up in the sky because they like the astrology side of it. Mm-hmm. And I don't judge.
And all that stuff has astronomical origins, and that's why they can get that information from your blog, which is an astronomy blog, not an astrology blog. Yeah, it's exactly right. I mean, neither of us can take an official position for the entirety of the RASC on this front, but astronomy is what RASC does, and astrology is fun for folks. If they want to have fun, they can have fun.
Yeah, yeah.
It's entertainment. Right?
And now you'll know, hopefully at the end of the session, you'll know a little bit more what is meant by the certain terms that people are reading or hearing or using when they do astrology. So, we'll make this a bit of a conversation. I have notes, so I put some notes together. Again, I'm not an expert, but I just want everyone to think back. So in ancient times, astrologers were the astronomers, right? And this is true in all cultures around the world, not just, we're used to thinking of astrology maybe from Middle East and into Europe, but China and Egypt and Mesoamerica, they all had their sky watchers, people observing the heavens, taking measurements, recording things. And that was astrology, but it was also astronomy. And one of the neat definitions that I saw was that the astronomer side of the coin, was the person who was making the observations and then recording them. And then the astrologer is interpreting, doing the interpretation. And that's where things, diverge now for modern astronomers. We don't, we appreciate the way that people observe the sky. Much of our science is built on those records, right? Things like the Crab Nebula in 1054 AD were recorded by the Chinese astrologers in their annals. And so that we can now, that's a fantastic data point that we had that point that supernova occurred. And now we can view that same object 1,000 years later and see how things have changed. So,
and our observational techniques have changed as well. I think it's in human nature to look for patterns and stuff, which is why a lot of this has come up in different cultures. Everyone looks for patterns, and the stars being up there is certainly a reason enough to look for patterns and to be able to predict things that might happen. And, when certain stars are in certain locations, when does the season change, all that sort of stuff. And yeah, so it's just that we've improved a lot of our observing techniques, and we've learned a lot more about how the universe works. And we can certainly see a lot farther and in a lot more detail, a lot more granularity than we could in, let's say, 1000 BC, when this stuff was starting to happen. We have big telescopes now.
So speaking of that, one of the cool things that I like to show people when I'm visiting schools and using my planetarium is because the planetarium software lets us travel through space and location. So I'll fly us to ancient Egypt, and I'll set the date, and I'm going to show you in a moment, back to the middle of the summer. And someone's job, the court astrologer, their job was to watch the dawn sky for the day on which the bright star Sirius rose with the sun at the same time. That's called heliacal rising, and that'll be a term that astrologers would use. It's just an object that rises or clears the horizon at the same time as the sun does. Now, because Sirius is such a bright star, it was visible in those moments, as the sun was rising. Not every star can hold its own that way. So here's that. Let me share my screen. I'll bring up my stellarium and share my screen. And I'll demonstrate this. There we go. I'll just take you and I out of the picture here. So in my planetarium, I actually have a cool panorama of the pyramids and everything. It's really neat. But in this case, I've just got a flat horizon. And so this is now set to the year 2000 BC in Cairo, Egypt. Let's see down here, Earth Cairo, on July 5th. And on that date, just as the sun is rising, so is the bright star Sirius. And this would be important because then it would be a marker in the year to inform them as to when the Nile would flood, and they could begin planning for that process and the planting and so on that goes with that. It always happened in July, early July, and it delivered the expression, the dog days of summer, because Sirius was the dog star, part of the constellation of Canis Major. I'll just bring it up here so you can see the dog. And so people understanding that the star Sirius was in the sky with the sun, they had the idea that the two objects were combining their heat and making it hotter in the summer, even though, of course, we know that's not nearly the case. But that's where that came from, the dog days of summer. And one way the court astrologer would be used to help, manage human society at the time. They would mark the things like Stonehenge would mark the solstice, the equinoxes, so that they could tell when spring was arriving. And so many cultures around the world use the equinox as their new year, their renewal time. Now, in terms of, let me just bring us back to now. I'll take us back home. Reset. All right. So I was giving some thought to, how astrology could have come to be thought to influence human beings. Now, as scientists, we really only know a few forces that could act at astronomical distances, right? We know of gravity, we know of magnetism and radiation, in the sense that, our distance from the sun varies a few percent through the course of the year. So maybe we get a little more or a little less heat. So I don't know whether that could possibly, have any influence on humans from an astrology point of view. But really, most people think that, well, gravity is the only thing that could really be affecting us. But if you know about gravity and you know how it works, then you realize that the moon tugs on the earth, and it tugs on you and me, because the amount of gravitational force exerted between two objects with mass relate to how much mass they have and their distance apart. I'm not going to get into the math formulas right now, but if you could share that link that I gave you in the notes, it's a really neat tool, a gravity calculator tool, where you could type in two masses and their distances apart, and you could do, a dad and the child standing 2 meters apart and see how much gravitational force they pull on each other. And then you could type in the moon and that kind of thing. And so I did a little back of the envelope calculation on that. And I worked out that the moon still exerts more force on you than your friend would standing a couple of meters away. But it would be about the same as your house.
Okay.
So the mass of your house on you would exert, maybe the same pull on you than the moon does. So, but when you get past that, it really drops off. The other celestial object is so much farther away that their gravitational influence on human beings would be just minuscule. So I gave you a little note. I don't know if you want to type that little list of
I don't
relative
know how
gravity
superscripts will work. The superscripts didn't work. If there's a negative something, it means 10 to the negative whatever the number is.
All right. Yeah. Well, we can just mention a couple things. So if the moon exerts an amount equal to one, a force of one, relatively speaking, on somebody or on the earth, then the sun would be 0.4 of that, or 40%. So, they're in the same range. But then the next smallest one is Venus. So Venus is 6 times 10 to the minus 5, less than that. So that's a millionth, 1/6 millionth of the force, the gravitational force. And then it drops way down from there when you get out to the other planets. So as astronomers, we don't really see where the planets are in the sky could have an impact on human beings, but we really can't make that connection from a known force of nature like gravity. But got to keep an open mind. Maybe there's other things in the quantum realm or something else that could come into play in the future.
That is worth noting as well, just that science changes over time and our understanding of things changes over time. And this is all true based on our understanding up until this point. So based on our understanding of how gravity affects the things around it, the impact of the planets would have, in the words, I think it was the words of Carl Sagan, the gravity of the doctor standing next to you while you were being born has more of an effect on you than the gravity of Mars or something along those lines.
Yeah. So as astronomers and scientists, we can't make that, you can't see how that would work, but I'm not judging. If you're interested into that belief, then you have every right to believe that. Now, just rewinding a little bit more about how things worked over the ages in astronomy and astrology. So the first sort of recorded astrology / astronomy was by the Babylonians. So we're talking about 3000 to 1000 BC. So several millennia ago, many millennia ago. And their job was to, as I showed, observe the heavens, look for phenomenon like the rising of Sirius and the way that might influence life, when the seasons would change and so on. And usually it was the same person. The astrologer was the astronomer, it was the same person. And that happened in many other cultures. In Europe, in medieval Europe, a lot of times and in China and other places, the king, the rulers, the court would pay the royal astrologer or the royal astronomer to do this, because if you could predict when, say, an eclipse would happen, then it gave you an edge, it gave you an advantage in the way of controlling the masses and that kind of thing, right? They would also want the court astrologer to, record the years, create calendars, mark the, how long did my father reign or my family reign, and that was important to people in those days. Names that you might recognize in history that would have been considered astrologers would have been Ptolemy from ancient Egypt. And we, as astronomers, we get a lot from Ptolemy. He created some of the earliest defined some of the earliest constellations and noted them in some of our records, so that we now continue using the same patterns that he saw. Confucius in China was considered an astrologer at the time. And then even in Europe, people like Tycho Brahe, Johannes Kepler, Galileo probably thought of themselves as astrologers in a sense, except that they were the people who were beginning to formalize it in the sense and become scientists. And that's kind of, as in a sense, where things began to diverge from that classic idea. So around the 17th century or so, when they invented clocks, we could record time, we could make predictions, and then we could measure more accurately. That's when the scientific method sort of came into the forefront of this idea of astronomy as a science.
And it was, over time, even the definition of science has changed. For a long time, philosophy was science. And then now we've started to turn science into its own separate discipline from philosophy. It still crosses over when you're doing things like theoretical physics, and you have to think about the possibility of stuff and then test it with experimental physics. But even that definition has kind of changed over time.
I think alchemy would be draw a similar parallel. So Isaac Newton was considered himself an alchemist. He was studying the natural environment, elements, and the way that they interacted. And that's now become chemistry in the modern day, right? So a lot of the early sciences had an informal side to them in the beginning, and now they become more formalized. Mm-hmm. So let's talk about some astrology, some terms that are common to astronomy and astrology, and just get into some of that. And we can, answer questions from the audience and go into that. So I'm going to use stellarium. I'm going to bring up, I've already got the ecliptic on here. So the ecliptic is the path that the sun takes through the sky in the course of a year. And the constellations that it visits are the Zodiac. So that's what they are. That's why they're famous, is because those are the 13, actually. They're not just 12, but there are 13 constellations that the sun spends time in the course of a year because of Earth's orbit around the sun. And you can see that I've got that plotted as a straight line across the sky here. And I'm going to bring up the celestial equator as well. So let's bring up the celestial equator. Date. And we're going to bring up some markings on the ecliptic, and I'm going to bring up the solstices and the equinoxes. So we got
At
ourselves.
some point, just a heads up for those who are watching, I know a couple people have asked about Stellarium. We do have a basic Stellarium, how to use it on YouTube, and eventually we'll run one that's an advanced one so that you can master all of the tips and tricks that Chris is currently utilizing.
So the ecliptic, which is the orangey, orange or yellow line across the screen here, that encircles the Earth around the sky. So it's 360 degrees around the sky. And the ancient Babylonians, recognizing, and other cultures, but recognizing that the sun follows that track through the stars, that became the basis or the core of their astrology / astronomy. So that was used for many, many millennia, but around 400 BC, we have records that indicate that the Babylonians sort of formalized the whole process, and they worked out that they should divide the ecliptic into 12 equal pie slices of 30 degrees. So 30 times 12 being 360-degree circle. And each of those 30-degree chunks became a star sign and was really dominated by one of the main constellations. So you can see here I've got Taurus. And just to show you what 30 degrees in the sky would look like, that would be about 3 of your fists side to side at arm's length. But if I put up my measuring tool here, I could measure the width of, so I don't know if you can see that line that I'm drawing. That's 30 degrees in the sky. So it's about from Taurus's horn tip to kind of past the Pleiades. Now, all of these red boxes that I've got shown in here, those are the constellation boundaries that were defined in 1930 by the International Astronomical Union. So they were not used by the ancient astrologers from antiquity. These are a modern creation designed to be able to map where everything is in the sky without any overlap, so that every object, every star, every deep sky object in the sky fits into one of the constellations using that boundary system. And they were based upon, they have funny jagged boundaries based on traditionally what stars were assigned to which constellations, right? So it's not an even pattern. But roughly speaking, the Babylonians, they decided to use these 30-degree swaths, and it just works out that each of these constellation covers about 30 degrees along the ecliptic. And their dividing lines between the end of one constellation and the start of the next one would be the most easterly bright star in the constellation. So would be the last one to rise in the east and the last one to set for that constellation in the west. So for example, Pollux, the star Pollux, is Beta Geminorum. It would be the sort of marker starting the star sign for Gemini. Let's see, in terms of, I'm just going to make the Earth disappear here.
And there was a question in the YouTube chat, which I half answered because I don't necessarily know for sure. In astrology, these are called houses. Is that right? I think so. Based on what I was looking up, I think yes. There are 12 houses, and it's the circle divided by 12.
Yeah, the houses are dividing the part of the sky that's above the horizon into 12 1-hour sections, and they actually they shift through the stars.
Oh,
right?
That's interesting. Okay.
Yeah, so it'd be like east would be 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, and around. So the house would be when you were born, what constellation or what planet was in what house of the sky.
Okay. So it's
how high above the horizon was it? Sort of that kind of thing.
Right. Okay.
That's my understanding. Again, if you're an astrologer, you can shout at us.
I also know that there's several different types of astrology, and there's the one that goes by where the constellations were when it was first developed, and then one that goes by where they've now shifted.
Yes. So we're going to get into that too.
We'll get into that. Warren, your question about that, we will also answer that later because that's similar.
Yeah. So nowadays, astronomy Astronomers have a coordinate system called declination for north-south and right ascension for east to west. And the coordinate system, it's kind of like latitude and longitude. But whereas on Earth, the origin of the latitude-longitude system runs through Greenwich, England, and then crosses the equator down in Africa. In the sky, the sphere of the sky, that origin point is right here, where I'm pointing right now. This is called, it's called the first point of Aries. That's what that funny little symbol is. That's the ram. That's Aries, the ram. That's marked in the sky in stellarium using this little ram symbol. And you can see the 0 degree mark on here is giving the 0 degrees along the ecliptic point. So that's the first point of Aries. Now you can see that it isn't in Aries, the constellation. All right. Aries is way back over here. So what you have to do is, I just finished saying that the Babylonians set this up in 400 BC. So now I use stellarium. Let's see if I can do this. 400. And set this to 0 and to negative. One more go. So look at that. On 400 BC, the first point of Aries was in Aries. And this is what you were just saying, that today, all the star signs and the origins of the astrology that people use for that have evolved away from the way they were when they were set up back in 400 BC by the early people in antiquity. So let's just see. Yeah. So and just to complete the thought. So the first day of spring occurs when the sun is sitting at this spot in the sky. And you can see that it's the point where the celestial equator and the ecliptic intersect. And so what happens is the sun migrates along the ecliptic from west to east. And on the first day of spring, the sun hits the intersection point and enters the northern half of the sky. And that triggers spring and the warmer part of the year for us.
And just for some super basic knowledge, in case folks aren't aware, that is, usually around March 21st. And on that day, if you're looking at the larger scale of how the sun is placed compared to the Earth, the sun will be directly over the equator at that point, which is, I know, hard to interpret sometimes from looking at it ground up. So if you move yourself in your visualization world outside of the Earth, the sun would be directly over the equator if you were looking down on it.
Yeah. So I'm just going to advance. I've got the date set to February 19th. If I just advance every day, see the sun is climbing up higher and higher and higher. And then when we get to March 20th, 2021, then that's the day that the sun is, maybe I'm going to go back a day. You know, it depends on the exact minute that the sun crosses the boundary. Mm-hmm. So you've got that point in the sky, and that was the origin point for the astrologers along the zodiac. So the zodiac went around from there, and it's also the coordinate system for modern astronomy. It's the 0 hours right ascension mark in the sky. Mm-hmm. But it varies in position. It varies in the sky according to the year, because the Earth's northern axis of rotation is precessing slowly like a top.
Wow.
So that, so let me see if I've got that. I mentioned that later on. In my notes, I talk about the age of Aquarius, so we'll get into it.
Sorry, we can talk about that too, because that's also relevant to this current conversation.
All right, so basically, let's just skip ahead. Let's see, where's that age of Aquarius stuff?
All of this has to kind of do with how the Earth wobbles.
So right now, the Earth's axis of rotation points towards Polaris, or within a degree of Polaris. But that's a function of the era that we live in. So in the far past and in the far future, that axis of rotation will point at different stars in the sky. Back in 400 BC, the location was such that this intersection point on the ecliptic was in Aries. And now, because the whole system has been rotated out of view, it's now swung into Pisces. So the time it takes for the Earth to complete one of those wobbles is 25,800 years. And if you take the 12 zodiac signs and divide that into the 25,800, you get, 2,160 years. And so depending on where the origin of the system is, the 0 hour, what constellation it is, that would be the age of that constellation. So the age of Aquarius will happen in around 2600 AD, because this intersection point will migrate and pass into Aquarius in about 600 years. Go ahead.
However, I think some people say that we're in the age of Aries right now. And that's because of these two different types of astrology. Hold on, I have them written down: tropical astrology and then sidereal astrology.
Yes. And again, I mean, I know about astronomy. I'm not an astrologer.
Yeah.
So I'm doing my best to explain it as I understand it from an astronomer's point of view.
And
so you do get, yeah, go ahead.
I was going to mention, I can explain it from what I understand, which is also not an astrologer, but if you were going to cover it, I can leave it.
No, please share.
So I was essentially, because of this wobbling of the Earth, which I found out Ptolemy, actually someone before Ptolemy knew about, Hipparchus knew about it back in 130 BC. So this was a while ago. Knew that the Earth was sort of like wobbling. The North Pole of the Earth was moving such that the position of the sun seemed to change at different times of the year. Hence why we're in Pisces, and then there are these different ages. And so at the time it was in Aries, and then some astrologers go by what it was when the system was developed, which is tropical astrology. So then it's still in Aries in its own way. And Aries, not as a constellation, but as an idea, has moved into the constellation of Pisces because that's where the sun actually is. So it's like, in effect, shifting all of the ideas of the constellations, the areas of the constellations with the current position of the sun, the way the sun rotates. And then there's sidereal astrology, which is mostly practiced, I believe, I think it's in Hinduism, maybe? I'm not sure. But that follows what's actually happening in the sky right now. So in sidereal astronomy, we're in the age of Pisces because the sun is in Pisces. Whereas in tropical astrology, we're in the age of Aries because Aries has shifted along with Pisces or something along those lines. It's very odd.
Okay, we'll move on.
Yeah.
I just thought, just briefly, because it's interesting to think about or look or show, I'm just going to open up in Stellarium here. If you go to the markings tab, you can type in the let's see, where's the precession circle here. There it is. And you can label it. And so now you can see that around 2000 AD, Polaris, and I'll just let the sun go down here so we can see. So here's around midnight, I'll go back to now as well. There we go. So around midnight, you can see Polaris here in the sky, and it's currently the star closest to the Earth's axis of rotation. And you can see every 1,000 years how that axis of rotation will point to a different patch of the sky. Now, the North Celestial Pole won't descend in the sky. The stars will move up to sit at that location, because the North Celestial Pole for us will always be 40 odd degrees above the northern horizon. All right, so don't get confused. It's not like the North Pole is going to drop down to the horizon.
No, this is just our visual representative of where the North Pole is, because the North Pole is just an invisible line that goes up from the top of the world.
Yeah, so I did a Skylights blog a month or two ago where I'd called Cepheus the king of the pole, because in a few thousand years, his stars will be the pole stars for the Earth. So anyway, that's a fun little diversion
Prepare now to find Cepheus, because I find Cepheus very hard to find. Whereas the Little Dipper is a lot easier.
Yeah. Yeah, well, I mean, Polaris itself isn't all that bright of a star. So one day we'll get Vega as our pole star in the far future, or for our descendants.
Vega's nice and bright, easy to find.
All right, so let's move on to a few other fun things here about the zodiac. So I mentioned that there are actually 13 constellations that touch the zodiac. And of course, because the sun is in those stars at the current time, we're only seeing the stars opposite the sun in the nighttime sky. So right now, let's go back. Let me just advance the time here around to noontime to bring up the sun. So we can see that right now the sun is in the Sagittarius Capricornus area. And a month ago, the sun was sitting here, and you can see that here's Scorpius, here's Libra, Scorpius, Sagittarius, and this is Ophiuchus. Ophiuchus is the mysterious 13th constellation that the sun spends time in, that the astrologers didn't bother with, because to them it was just one star. This is the serpent bear. His one foot sticks down and trips the sun right around my birthday in December, December 13th. So Randy Atwood and I used to tease each other that we were Ophiuchans. All right. What else can we talk about? All right, let's see. I talked about the IAU boundaries. Yeah, so let's just bring this ahead. So because all the planets, the sun stays in the ecliptic all the time, and the moon and the other planets all orbit the sun in roughly the same plane. So the planets all find themselves in or among the zodiac constellations as well. So that adds to the ideas behind astrology, because they're also dealing with not only where the sun is and what stars are up, but then where the planets are and which star signs that they were in when you were born, or however they want that out. Now, some people might have heard the term cusp. So the cusp is when the sun is on the boundary between two star signs or two zodiac constellations. So the cusp is when you're entering one, leaving the other. Let's see, elements. So some people mention that one of the four elements, fire, water, earth, and wind, and relate them to particular zodiac constellations. And I don't see any logical connection there. We do have constellations on the zodiac that are water-based and others that aren't. So we have Pisces and Aquarius. Do we have a couple others? Capricornus is the sea goat.
Technically, although he's not on the zodiac.
But it didn't look as if the way that the elements were assigned to the constellations had any logic in that sense that I saw. So if you're studying astrology, you figure that out, I guess, yourself. Interesting to note that the ancient Chinese astronomers actually assigned the elements to the bright planets. So, but they added the fifth element of metal. So you've got Mars is the fire planet, Mercury is the water planet, Venus is the metal planet, and we've got Earth and wood would be Jupiter and Saturn. Let's see. Okay, we talked about the age of Aquarius and so on. Now we can get a little more technical. Do you have any questions before we press on?
So far, there haven't been any, but if you do have questions, please do ask them in the Q&A or in the YouTube chat. And if you're planning secret birthday parties for Chris now that you know his birthday, please let me know.
All right, good. All right, so some other terminology. So nodes. Let's talk about nodes. So I'm going to get rid of some of my markings on here. Let's get rid of equinoxes. And
as you're doing this, sorry, Cicely just mentioned, who's also planning your secret birthday party, Chris, is a Cuspian devil, as you said, and I love it. I guess I don't know what the two constellations are, but Lego Leo. Oh, because Libra and Virgo. You're on the combination of Libra and Virgo. I love it. That's hilarious.
I can see how that would work. Yeah.
Oh, Leo. Yeah, Leo and Virgo, not Libra.
So in Stellarium, you can go into the viewing options and go to the SSO, the Solar System tab, and you can ask to see the orbits of the planets. And then you can select only orbit for a single planet that I select. So if you don't select a planet, you get them all these crazy red stripes. Or if I just pick the moon, I just get the moon's orbit. And the method in my madness is that I want to bring it down to tonight's sky around sunset and talk about Mercury. So there's Mercury. And if the next few days, Mercury's going to get higher and more easily visible in the sky. And one thing you can notice is that Mercury's orbit is not tight to the ecliptic, right? This is true of Mercury and Venus. Both have orbits that are kind of broad compared to the ecliptic, whereas the outer planets like Jupiter and Saturn, Uranus and Neptune, they stay rather close to the ecliptic all the time. So the nodes are the places where where two orbits intersect. So this ecliptic line is really Earth's orbit, and then the point where Mercury would cross. Now this is not the node. Let me go back. We're not actually seeing Mercury's node right now because it's not near there, but at different times of the year, Mercury will be near the sun because its orbit will be crossing close to the ecliptic. So a node is the place where the two orbits intersect. And when the sun and the moon are both near the node where the moon's orbit intersects the ecliptic, that's when you get eclipses. So if the moon is between us and the sun, we get a solar eclipse. But most of the time, of course, the moon passes by the sun, but misses it north or south of the sun. So we don't see an eclipse. It's just those rare occasions. The next solar eclipse, if anybody's interested, is June 10th of 2021. So let's jump ahead to June 10th, 2021.
Half is in Canada.
Yes, this one's going to be visible. So let's center in the moon. And I believe it's in the morning sky. And I've got the moon enlarged. Let me just get it.
Something's not right there. There we go.
So this is visible in Canada, yeah. And it's a pre-dawn event, unfortunately, for some. And we only get a partial eclipse. So this is the sky from Toronto at about 6:05 a.m. Eastern time on June 10th. And you can see that the ecliptic is here, and this other line intersecting it, that would be the node where the moon's orbit and the sun and the Earth's orbit are intersecting, producing the eclipse effect. Because the sun and the moon are both a half a degree in diameter, apparent diameter in the sky, they don't need to be right at the node to produce an eclipse because they can be offset, but still they're broad enough that they can still overlap one another and get a partial eclipse effect.
Mm-hmm.
Now, if an inner planet, if we arrive at the point where an inner planet's orbit intersects the ecliptic, and if the geometry is right, then we can get what's called a transit. And so we can get a transit of Mercury or a transit of Venus, where it's effectively the same thing as an eclipse. It's the object, the inner planet, crossing the sun's disk, except that they're too small and far away to cover the sun up. So we call it a transit. So technically, a solar eclipse is a lunar transit.
Right. It's anything going between us and the sun is a transit.
Venus transits and Mercury Venus transits are pretty rare. They happen in pairs every 112 years or so. The last Venus transits were in 2004 and 2012 in June. And so, I mean, I could show that if we want to. The next one will happen, I think, in 2117.
This is where I only got into astronomy in about 2017. So I missed that by 5 years. And now I have to wait another 100 and whatever.
Yeah, so, depending on how longevity goes, there are people that are around today that might be around for the next one.
Gotta maintain those telomeres of mine.
Except once we have space tourism, then you could, You can fly, because really you can do this in stellarium. You can park yourself on any planet, and then you can look up when the Earth will transit the sun as viewed from Mars,
Oh,
or as
that's
viewed
cool.
from Jupiter or Saturn. And so as we become interplanetary species, then we might be able to take our vacation on the moons of Jupiter in order to observe the Earth transiting the sun at a certain time. This kind of thing can happen.
Someone start that tourism industry now. Get on that early.
Now, notice that let me just go back in here to show the directions. So notice that the ecliptic, right? The ecliptic is on an angle with respect to the horizon, and it varies up and down a little bit depending on the time of the year. And if you swing around, so if you're facing kind of east in the morning, north is to the upper left. So this is the northern half of the sky, and this is the southern half of the sky. And you could do the same thing in the evening. So we could go to, say, 18 o'clock. Let's go back to now. Face west. And again, there's Polaris up here. So now when you're facing west, the north half of the sky is to the upper right, and the southern half of the sky is to the lower left. So the idea behind the nodes, let me just bring back Mercury here and look at that. Just get Mercury coming up.
And this is the next couple days. So if you're feeling adventurous, you should be able to see Mercury after sunset if you don't have clouds.
Yes. So in astrology, you might hear the term ascending node or descending node. And what those are referring to is when the planet is crossing the ecliptic. So if it's crossing from the southern side of the ecliptic into the northern sky, then that's when Mercury's here. And so if I advance the date, you can see that somewhere around January 24th, Mercury will be at its ascending node, right? And then a couple of months hence, when we get Mercury back into the pre-dawn sky, then at some point it'll descend into the southern half, and we'll get Mercury at the descending node. So that might be a term that you've heard both in astronomy and astrology, ascending node and descending node. Now for astronomy, I rarely make note of when planets are doing this when I'm reporting on what they're up to, because it doesn't have that much effect on the astronomer or stargazer. Basically the rule of thumb is that if Mercury's in the northern part of the sky, it's more observable for us. It's more easily visible for us because it's higher than the ecliptic. That's the only thing that we do in astronomy.
I always noted the greatest elongation, like the furthest point, which would be very close to the ascending node, but may not actually be the ascending node or descending node or what have you. But that point where it's furthest away from the sun, that's the one I always note.
Yeah, so it's basically the same. So on the 23rd of January, Mercury will be at its greatest eastern elongation, and that's its greatest angular distance from the sun, which means that it sets as late as it can after the sun. And that means that it has the opportunity to shine in the darker sky. How's our time doing? 14, good.
Yeah, 40 minutes. Yeah.
So that's something to look out for in the next number of days. What are we here? On Saturday, that'll be Mercury at maximum visibility when it's at its greatest elongation.
We have a couple questions about nodes, which I did not notice until now. Do you know what nodes mean in astrology? I've never looked it up. What they interpret it to be.
No, I don't. And every aspect of a planetary motion is somehow related to a meaning in astrology. So that's why all of these astronomical terms for what planets do are found in astrology. I'm not an expert to know.
I'm not sure what the actual nodes are.
Yeah.
Okay, I have these two questions are interesting. ascending nodes and descending nodes are always at the ecliptic, but is it always where the orbital line appears to turn? So at that greatest elongation point, for example. And no, because not all planets are in the interior planets, right?
Right. Yeah. No, it can vary somewhat. Yeah. Yeah.
And as well with like Jupiter and Saturn, they don't, I guess they where they appear to turn is based more on where we are in our orbit relative to them, and less about where they
So
are.
Jupiter and Saturn don't turn in that sense.
No.
We'll get into retrograde and stationary into that in a few minutes. But
yes, and then
if I pick on, say, Jupiter here, you can see that Jupiter's orbit is quite close to the ecliptic, and somewhere down here they cross. So that would be its node. But that'll happen near conjunction, and we'll get into conjunction in a few minutes as well.
right. And then, okay, this is, I have no idea if you know the answer for this one, but I love the thought process on this question. How do Australian astronomers name their ascending nodes and descending nodes? Are they reversed or are they the same?
I don't know for sure, but I imagine that astronomy is standardized around the world. So the fact that we adopted ascending to mean south to north, I think they have to live with that.
Yeah, sorry, Australians. we're the majority up here in the Northern Hemisphere.
Yeah. I think they just have to live with that. But that's a good question. All right, let's see what else have we got here. All right, let's talk about heliocentric latitude is another name. So basically heliocentric latitude. Now remember that I just finished saying that when you're facing west in the evening, north is up this way. So if I'll draw the equatorial grid here. So these lines face north, okay? These face east and west. So south is down this way, north is this way. It's messy. Earth is messy because of Earth's axis being tilted by 23.5 degrees. I'm sorry, that's the way we have to live with it. But basically, the heliocentric latitude would be the number of degrees north or south of the ecliptic. That's all that means. So right now, Mercury on Saturday, Mercury's heliocentric latitude will be 0.
Because it's on the ecliptic.
Because it's on the ecliptic. Let's see if I have another.
That would matter a fair amount for things like
there's the
transits.
ecliptic. Yeah, there's the ecliptic
cool.
grid.
Yeah,
that's the ecliptic grid. Yeah, let me turn that off. All right, so let's talk about retrograde and prograde and things like that. And this is better. This is cool because this is stuff you need to know for the exam in astronomy class. So this is important to know.
All right, students, listen, get your pens out.
Yeah. So everything's in motion in the solar system. If you were able to park yourself above the solar system and looking down, say over the sun, everything is traveling counterclockwise. So and that's all to do with the angular momentum left over when the solar system was formed. So the cloud that the solar system was formed from had a rotation aspect, and that rotation aspect has then been baked into everything continuing to move since things were formed. So the planets go counterclockwise around the sun viewed from the north, and then the moons, for the most part, do the same thing. Unless the moon has been captured by some other means or been knocked, because the early solar system had some dynamics going on, knocking things about. There were some exceptions to that, but generally that's the rule. So that means that sitting here on Earth, in normal terms, a planet will seem to move eastward, and you'd have to wrap your head around it. But if you're moving counterclockwise from looking down from the north, that means that from our perspective on a moving Earth, the planets, when they're in their regular motions, are traveling eastward along the ecliptic. And so the complexity comes in because we're viewing them while we're moving at the same time, right? And everything's moving at different speeds. So And what we're measuring this with respect to are the fixed stars in the background. So the stars in the background are basically locked in place, and the planets are moving in front of them. So now don't look at Mercury for a minute. let's worry about, let's go up and look at Mars. So here's Mars. So if I advance the date in Stellarium from tonight, you're going to see Mars is marching a little bit right to left compared to the stars around it. And that's called prograde motion. Now, because all the planets are racing around this racetrack around the sun and at various speeds, there are times when the Earth, being faster than the outer planets, can pass them on the inside track. And so most of the time, we're both moving the same way, but in the periods when Earth is starting to move into the gap between the planet and the sun, then from our point of view, we're overtaking it and we're causing that planet to look like it's slowing down in its motion. And there does come a point when we get to a point where the geometry lines up that the planet looks like it's stopped compared to the stars. And then as we sort of speed up in the car faster, the planet looks like it starts going backwards compared to the stars. And that's what retrograde motion is. And let me see if I can find, I don't have it preset up, but in Stellarium, you can actually take a planet and plot its trajectory in the sky over several months, and you can make it form that zigzag loop.
And we saw that zigzag around when Mars was at opposition, which was some earlier time in COVID. I've lost track of how time marches on. I don't know. Was that October?
Yes.
October.
Yes.
Yeah. So it did that little zigzag.
Yeah. So what I could do here is I could drop us back to mid-October. Let's do that. Let's bring up Mars into the view again here, and I'll just show you how it looks. So there's Mars around the middle of the night, and I could go here to my handy dandy ephemeris plotter, and I could pick Mars.
We aspire to have the Stellarium skills that Chris possesses.
So if I go to say, let's go to say April to, I go to December 31st of 2020, plot it every day and calculate. And
whoa.
that, and now you can see the loop. I only plotted part of the loop. So Mars was normally moving eastward compared to the planets until probably, let's see, go back in time. So around mid-September, and actually if I take away the tilt of the Earth, I can get rid of some of this geometry. So around mid-September, Earth started overtaking Mars on the inside track. That made Mars look like it stood still around this night. And then every night after that, Mars seemed to go backwards.
As we proverbially drove past it.
Yeah. And then it got to a point where we were actually between Mars and the sun. And that was around October 13th. That's opposition. Okay. And then a number of weeks after that, the geometry worked out that now we're both appearing to move forward. So Mars would again pause, and then it would start moving east again. So this is prograde, retrograde, and then prograde again. So the planets spend most of their time prograde and only go retrograde when Earth is between them and the sun, that few month interval. It's about, I think I wrote down, between 2 and 5 months, depending on the planet, is how long the retrograde period lasts. That's for the outer planets. The inner planets are more complicated than that because they're moving faster and it's tricky. But you can have, yeah, you can have
gotten through the complicated part. Well, you were wrong.
Yeah. So let's clean this up, get rid of that. And I'll go back forward to tonight. And again, you know, some of these concepts, you could spend devote a whole session to them if you really wanted to, just to explain them because they're tricky. All right, what else do I want to say about that? So prograde, retrograde. So the inner planets, when we're seeing them in the evening, so as Mercury is, so let's go back and look at Mercury in the evening sky. So let's just zoom in on Mercury here. So if you compare Mercury to the stars of Capricornus that are beyond it, I think I can do, if I advance the date, then Mercury is moving east compared to those stars. It's heading this way, right? So it's prograde. Let me draw that orbit again until Saturday. And again, I can just take out the slope of the Earth. And then after Saturday, Mercury will continue to move prograde, but at some point it'll start winding back. So it's really complicated because
it'll go too fast compared to the movement of itself going the other way, and then it'll kind of overtake itself.
Yeah. Here's another way you can do it. In Stellarium, you could pick a star, lock the screen on the star. All right, so here's Mercury moving prograde east towards that star. And then around here it stops, and then it starts heading back the other way. So that's retrograde. And it's not easy to observe in the sky, but that's what's happening. That's what the term means. Let's see.
I'm gonna quickly. I'm trying to type this out, and it's not going well. Ashi asked a question about the planets. The planets don't physically move backwards. It just means the Earth has overtaken it for retrograde motion of the outer planets. Yes, and Chris had a really good, the only visualization that's ever worked for me back when Mars is in opposition, which is if you're on a highway in Calgary and there's mountains in the background and you're passing another car, for a second as you're passing them, the car seems to be going backwards relative to the mountains behind it. And then as you get far enough ahead, they look like they're going in the right direction. And it's that appearance of the car going backwards relative to the mountains far away that is retrograde motion. It's the only description that's ever worked for me.
Yeah, it's a moving observer and a moving object that you're following along with, and then a fixed background. That's how you make it work. That's how you make it happen.
So none of the planets are ever going backwards. It's just the way it looks based on where we are.
Correct. They're continuously doing their loops around the sun at the, more or less the same speed. It does vary a little bit by whether they're at perihelion or aphelion, but viewed from above, the planets all orbit around the sun counterclockwise continuously. Nobody stops and turns direction.
That would be very hard to explain with physics.
So we touched on this a little bit earlier, but again, it's a term that's dealt with in astrology is the concept of conjunction. And so a conjunction happens when two objects are near each other or even superimposed on each other in the sky. We had the conjunction of Jupiter and Saturn last month, but that's a different kind of conjunction. So there's a bit of misinformation around that. So normally what we talk about when we talk about conjunction is conjunction of a planet or an object with the sun. So as we move around the sun during the course of the year, the planets will, compared to the sun, be farther from it, maybe opposite in the sky or near it in the sky. Mercury is a great example. So let's pick on Mercury here. And after Saturday, Mercury's going to reach the outer edge of its orbit and then start swinging back towards the sun. And it doesn't take long for us to lose sight of it because now we're getting into a bright twilight, right? But if I get rid of the Earth and I get rid of the atmosphere, then you can see that right around February 8th, from our point of view, Mercury's going to be in the same patch of the sky as the sun is, and that's called conjunction. Now, the inner planets can either be between us and the sun, or they can be on the far side of the sun. So they can be conjunction twice. So when they're between us and the sun, it's called inferior conjunction. And when they're beyond the sun, but in the same direction, it's called superior conjunction. So Mercury does conjunction frequently through the year, many, many times through the course of the year, because it's coming back about every 44 days. It's swinging back and forth. And technically the term conjunction, remember I said earlier about the ecliptic and how, where's our, let me just undo this. Where's Polaris? Here's Polaris up here. Remember I said that when you're looking at the ecliptic, north is to the upper right when you're facing west. So conjunction is actually defined as when the object crosses from east of the sun to the west of the sun. Let me just bring up the ecliptic grid here. So when Mercury moves from being east of the sun to west of the sun, that's conjunction, or heading the other way. It's also conjunction. So it can be heading east or heading west, and it can be superior or inferior. And Venus does that too. So Venus and Mercury both do that. But an outer planet can only have one kind of conjunction, only superior conjunction, because they never get between us and the sun. Right, because their orbits are bigger than Earth's.
And that's superior conjunction with the sun, as in it's on the other side of the sun from where we are.
Yeah. So here's Jupiter. So remember we had Jupiter low. Let's go back to tonight. Okay, and I'll bring this up again. So tonight's sky, there's the sun will go down. And Jupiter and Saturn are still there above the horizon after sunset. They're just way too low for us to see them. But they're every day heading lower and lower and lower towards the sun. And they're going to reach conjunction with the sun. I think it's around the 20, or towards the end of the month, they're going to hit the conjunction with the sun. But again, astronomers don't typically note that because they've long since been lost to view, right? But what they do mean is when Jupiter and Saturn reach solar conjunction around the end of January, then the day after they do that, they enter the morning sky. And then after a number of weeks and months, they'll appear in the pre-dawn. So that's the formal definition of conjunction. But everybody always talks about conjunctions as in terms of things that are just grouped together in the sky.
Mm-hmm.
And that's technically wrong. They're only a conjunction if they're at the same right ascension, formally. The proper term is a pulse, A-P-P-U-L-S-E, a pulse.
Oh,
that's
no.
a grouping. Yeah.
So wait, so right ascension is not it's declination is the one where you go from the equator up to the North Pole, and right ascension is left to right. So technically, like the Jupiter-Saturn conjunction that happened on December 21st, they passed each other in right ascension. So that did count. That was a real conjunction, right?
It was a real conjunction, yeah. So we can figure out when that happened. I'll just set this up. So again, east and west is on an angle in this diagram, right? That's what makes astronomy a bit tricky to master, is this tilted coordinate system. But yeah, the true conjunction happened around the 21st. So it was the time they were closest, but it was also a conjunction in the true astronomical point of
view. Whereas, I mean, like technically speaking, if you had, I don't know, some deep sky object at the same right ascension, but quite a distance at declination, and you had Jupiter going past it, would that count as a conjunction, even though they're far away?
Generally, they're closest to one another when they're also at true conjunction. But, you know, there are probably scenarios we could set up that look a little bit strange. The other thing to bear in mind is that if you're a RASC member and you've got the Observer's Handbook, they have the monthly pages of events. And they'll say that Jupiter is close to Saturn at some particular date and time. And they're recording the time, and I'll just set this up at the exact hour and minute when they're at the same right ascension. But they may not be above the horizon for us at that time.
Yeah, that might be, or it might be in the middle of the day, or
Yeah.
it might be like, yeah, it's not set up for best viewing. It's set up for technically correct.
Yeah. So you have to appreciate that. Well, I know that they're in the western sky, so I've got to wait for the next night or the previous evening to actually see them at their closest. So that's something to bear in mind. Just to give people some cool previews about what's coming up, I do have some mentions. I'm here in my notes. So let's see, May 28th of 2021. Let's bring up May 28th of 2021. And we're looking at Venus and Mercury. So let's get Venus and Mercury.
Also, as you're pulling that up, Bob asked to explain again the difference between conjunction and a pulse. And conjunction is when the two objects are at the same right ascension, and a pulse is when they appear close together at the least apparent distance between one celestial object and another. So if, for example, you're looking in the Observer's Handbook, it'll say things like, tomorrow night, I think, Mars and Uranus are 1.6 degrees apart. Yeah. So I guess that's in a pulse.
Yeah, well, that's a good example because when Uranus and Mars are close together, the first quarter moon will be in the sky near them.
So that's in a pulse for sure.
But they won't all three be at the same right ascension. So that's in a pulse. Whereas as individual pairs, they'll be at conjunction at particular times.
Right, okay. So a lot of the times when you'll see, for example, Chris's skylights or Sky News's This Week's Sky, anything like that, they'll be like 3 planets and the moon are all in the morning sky or whatever. That's in a pulse.
Yes. Yeah. But we're loose about we're informal about the way we use the language. But if you want to be precise, those are the precise definitions. So that's a good one. So when Mars and Uranus and the moon are together Thursday night, I think it's Thursday night, then at some point Mars and Uranus will have the same right ascension. At some point the moon and Mars, at some point the moon and Uranus,
but you can't name it all. Yeah.
And you can go into Stellarium, you could figure it out if you're interested, but visually it won't make that much impact.
Yeah.
So here's a preview for anybody interested. Here's a cool Venus and Mercury on May 28th, and then Mars and Venus on July 12th, and then Venus and the crescent moon on November. Let's do Venus and the crescent moon on November 7th. 7. Let's see when that is. Maybe it's in the pre-dawn. Here we go. That'll be a pretty sight with the moon and the crescent Venus after sunset in November.
That's lovely.
That'll be a neat one, yeah. Let's see, any other notes? Oh, go ahead.
A week and a bit from then, there's also a lunar eclipse.
Yes.
Yeah.
Right.
Which is visible in Canada, everywhere in Canada.
All right, let's go to tonight again. And let's just talk about, let's just show that Mars. So here's Mars and Uranus. And for those interested, I'm just going to bring up under markings and show you. So that's about that blue circle is about the field of view of a telescope at low magnification. Depending on your telescope, you might have a wider field of view than this. Let me just bring it up to a little bit bigger.
Also, just to be clear, in case it wasn't already obvious, we have now switched from astrology and the astronomy behind astrology and into just what's going to be happening in the next couple of weeks. Although perhaps, as Chris and I are not astrologers, maybe this is significant to people, but mostly we're talking about its significance in the astronomical sense now.
Yeah, I mean, well, it all shares the same roots, right?
Yeah.
So I just wanted to explain, what we mean by these things and then show some examples of how they're happening. So here's and if I bring up the equatorial grid, then at some point they'll share the same. See these numbers? These are hours and minutes. So at some point, let me just center on, say, Mars, for example. Then they'll be at the same right ascension on Thursday, but they won't be closest to each other. That happens maybe a little sooner. So it depends on the geometry.
That's a very useful demonstration because I did not picture that. Cool. Good to know.
Yeah. So I spend hours playing with Stellarium and looking at these things all the time. That's what I do. All right. So let's see what else we can talk about. How's our time going?
I wanted to just mention that in case you're in, like, if this has been inspirational to you and you're interested, and also, sorry, quickly responding to a question that was asked in the middle of me saying that, that is how a pulse is spelled. So you're right, APPULSE. But if you're interested in this, and also in general, if you're interested in the anthropological side of things, I ended up deep diving into archaeoastronomy while we were preparing for this session, which is not necessarily, it's the study of astronomy as it related to the people at the time. So, for example, maybe astrology doesn't make that much of a historical difference to us now. We're not building the CN Tower pointing at the North Pole or anything like that. But in, let's say, Neolithic times, there are several monuments that are pointed at where the sun would rise on the winter solstice, for example, or have set up their buildings somehow to relate to the stars. And so a lot of it is to do with trying to figure out how the astronomy or the astrology of the day applies to what people were doing. And I say this because there's a fantastic quote from one of the leaders in the field, which was, he described the field as a field with academic work of high quality at one end, but uncontrolled speculation bordering on lunacy at the other.
But doesn't it, I just find it incredibly impressive and much more impactful to understand just what some of these ancient monuments and creations that people have created, and the way that they tied them into the sky, into heavens, into astronomy. It's much more interesting when you find out that there's actually method to how they did it and why they did it.
Absolutely. And I know that I haven't been to them, but I know that there are some churches, I want to say they're in Florence. There's a church in Florence, but I'm sure there's several in Europe where the churches are built around where things were in space at specific times of the year. I know this because our past executive director and the now president of Mississauga, Randy, has been there before and shown us photos. And so they have all these different lines drawn on the floor for where all the different things in space were. And it's just so cool.
Just a couple more things. So another term that you might hear in astrology is aspect. And what aspect is, it's the angle of the line connecting the two planets. And again, astronomers don't ascribe any meaning to that, but astrologers do. And whether the line is more vertical, whether it's more angled or left right, has a meaning to them. But to us, it really, to astronomers, it really doesn't mean it. But that's what aspect means, if somebody's interested to know that. I only have a couple more things to talk about. One is oppositions. We talked about conjunctions. So conjunction is when objects share the same right ascension, or when a planet is at the same right ascension as the sun, in other words, close to the sun. Opposition, as you might appreciate, is when it's opposite the sun in the sky. And typically opposition is really important to astronomers because when a planet is at opposition, Earth is closest to it for the year. And when we're closest to it, that means it's brightest in the sky. In a telescope, it shows the biggest disk size. If it has moons, they'll be brighter than they are normally. So that may be a best time to try to see the moons of Mars, or maybe Triton or some other moon when it's near opposition. So we astronomers and stargazers really live for oppositions because they're important in that sense. They're the best viewing times for these objects. When the moon is full, it's at opposition every single month, right? It's opposite the sun in the sky. when the geometry is just right, we get a lunar eclipse because the alignment is such that the Earth is exactly between the moon and the sun, and we get the moon entering Earth's shadow and darkening because it's eclipsed. The technical term for that is a syzygy, SYZYGY. So when you hear the term supermoon, it's actually a perigee, a lunar perigee syzygy.
What a fun combination of words.
So a lunar perigee syzygy. Next time you're at the pub and you want to impress somebody, there's a little phrase you can pull out.
If you ever need a word that doesn't have any of the typical A-E-I-O-U vowels,
And
that is
Scrabble,
one of them.
yeah.
Yeah,
Scrabble.
I don't know if there are 3 Y tiles in Scrabble, but if there are.
The farther away that a planet is from the Earth, away from the sun, the more kind of regular its opposition is. So Mars being our next door neighbor, it reaches opposition every 780 days, roughly, about every almost 2.5 years. So the opposition we had in October won't be repeated until December of 2022. Whereas oppositions of Jupiter and Saturn and Uranus and Neptune, they tend to happen every single year. So we're going to skip a good view of Mars in 2021, but it'll be back in 2022 at the end. Whereas we'll get a good opposition for Jupiter, for Saturn, Uranus, and Neptune every single year. I think Jupiter is every 399 days, every Saturn is every 378 days. And those intervals are dictated more by what Earth's doing than by what the planet's doing, because we're moving faster compared to them.
Mm-hmm.
The last thing I had was planetary alignments. And planetary alignments ties back to the gravity idea at the beginning of the session, where we talked about how very little planets pull on a human being because they're so far away. So when they line up, it's hard to imagine why we would feel any influence or impact of that. But it's fun to observe, right? And so I looked up when the next exciting planetary alignment is going to happen. And of course, it's of interest to astronomers potentially, but it's very interesting to astrologers. And that is in February 10th of 2021. So let's go to February 10th of 2021. And if you've been paying attention to what's been going on with the planets, so there's the sun. Let me just bring this back. Bring this up.
That's a Wednesday.
That's up in the morning sky. And it's not going to be good for observing for us. Now, one thing that I haven't mentioned, you can see that we've got the moon, Saturn, Jupiter, and Venus all in the pre-dawn sky of February 10th and 11th, roughly. But they're low, so they're in the pre-dawn glow, and they're not going to be readily visible. But if you live near the equator, the ecliptic is much higher. So you can go into stellarium here, and you can crank your latitude on Earth down. Look how the ecliptic rises up.
Oh, wow.
And you get to about 0. So now we're living at the ecliptic. Now when we bring the sun down, the planets are more vertically above the sun, so they can shine in a darker sky. So if you're lucky enough to live at southerly latitudes, you can look for this nice Saturn, Venus, Jupiter grouping in the sky around then. The other cool part of that is if I take out, and this is where the astrologers get excited. If I bring up this view. So around February 10th, all within about 10 degrees of each other, we've got the sun, and I'll just put on the boundaries here. The sun, Jupiter, Venus,
Whoa.
Saturn, the moon, and Mercury all tucked. And I'll go to the 11th here just to bring the moon into the view. Yeah, there's Mercury, the sun, the moon, Jupiter, Saturn, and Venus all together in Southern Aries and Capricornus. And so the astrologers are excited about that. Me, I'm not so excited because I can't see it, but
yeah, we can't see it. Yeah.
but that's the sort of thing that people watch for.
It's in
So
the observer's handbook.
that's what I had to say about astrology. Hopefully it was education.
It's super cool. And it is neat to hear all the terms as they apply to both fields for sure. Quick question from Cicely, which I can answer as well, which is the difference between the inner planets and the outer planets' visibility at opposition. The main thing is that for the outer planets at opposition, they're visible at sunset. So
I should have mentioned, yeah.
Yes.
So inner planets never get to be opposition.
They're only, they have the oh no, I've forgotten. Conjunction. They have solar conjunctions.
Right. So
but we can't, they're never at opposition because we're outside of their.
So yeah, in terms of maximum visibility, maximum observability through your telescope, when the inner planets are at inferior conjunction is when we're closest to them. But they're also near the sun in the sky. So there's risks associated with using optics on those inner planets when they're that close to the sun in the sky. So you must be really careful about doing that. But if you want to see Venus and Jupiter when they're largest, you want to look at them while they're approaching or leaving inferior conjunction. But planets from Mars and beyond, they're biggest in the telescope when they're at opposition. Hopefully that's clear.
Yes. There's also a brief discussion going on over in the YouTube chat, which I meant to mention, so thank you for all talking about this, about tides. And this is where if the moon and the sun are in conjunction, yes, that's the right word, the tides are higher because you have gravity from both of them pulling on the ocean. Of course, they're both large and close. You're either large or close.
Yeah. So tides are maximum when at new moon, when the sun and the moon are both in the same direction of the sky. If the moon is near perigee at the same time, it's even stronger tides.
That's when
and you can also get strong tides when the moon is full and it's near perigee. It's a little bit tricky to think about, but you can create high tides when the moon and the sun are opposite each other in the sky and still in the same direction, still the same line. And it has an impact as well. It's
because the water turns sort of oval shaped, and so the middle part is the bulgiest.
So the people living where the moon is shining have high tides. The people living where the sun is shining have high tides, and the people in between get minimum water because it's being drawn the other way. Yeah, good point.
I just like tides because I'm a marine biologist, so I finally get to throw in little bits of that. And that, I believe, is all the questions we have. I did want to mention that there was a question from Damon, who is currently using their mom's computer. And so I wanted to address Damon's question, which is, if the sun lost power, how much % of the heat would we still be getting? But if the sun lost power, then it would have no heat and we would get none and it would be bad times. I think that's more of one of those hypothetical questions. I love those kinds of questions. But I think if the sun just like suddenly stopped producing light, it would take 8 minutes, but eventually we wouldn't have any.
Well, that's a really fascinating topic, and I hope you think about that some more. The Earth is powered by the sun, but the Earth is also powered by the Earth's interior heat. And I recommended a book a few months ago that I read. What's it called? Forget where it is right now, but it's about planets in different scenarios. And so if you had a rogue planet that wasn't orbiting a star, as long as it still had the geothermal heat from the interior, then potentially life could still survive on a planet underneath the surface, underground.
That's cool, because then on the surface it would be brutally cold. But that's very cool. Neat ideas to think about.
Yeah.
There's some really cool books out there.
The interior of the Earth is heated by the fact that it's still cooling, but also by the radioactive minerals in the Earth's core, the Earth's crust, that are generating heat. So we wouldn't be completely out of luck if the sun went out.
We just have to build a lot of tunnels.
Yeah, geothermal.
Awesome. Thanks everybody for coming. We really had a good time. It was nice to see everyone again. And we will see you all in 2 more weeks. We're going to be taking some time traveling trips, I believe, in 2 weeks, right, Chris?
Yes, you can step outside and journey through time by looking at different objects at different distances. And we'll talk about how we measure distances to things and that kind of thing as well.
So we will see you all in 2 weeks. And I hope you all have a wonderful time until then. Clear skies, even though that's extremely unlikely at this time of the year.
Clear skies, let's hope.
Take care, everybody. Bye-bye.
Keep looking up.